Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and Seth's brother Joel. My day is not going well. And here we have a question from an SAT. We're here to hopefully show you how to approach SAT math questions, if not any and all math questions. So this is from a calculator sectional. It's pretty obvious that a calculator is not going to be helpful. And here we go. It looks like, please look at it, stop it, and come back. Looks like it's a number theory question. Let x and y be numbers so that x is between y and negative y. Which of the following must be true all the time, okay? All the time. We have to make sure that that's clear. All the time,
Yes.
okay? Got it. Okay, great. So now,
Okay,
oh my God.
so let me give my impression.
Go ahead.
Go ahead. Okay. They are numbers.
Okay.
Therefore, okay, let me, yeah. So each must be positive, negative, or zero, right?
That's right.
And then how can they satisfy minus y strictly less than x and x is strictly less than y?
Good.
Well, y, first, how can they say that minus y is strictly less than plus y? Okay, so that cannot be if y is zero, and it cannot be if y is negative. So it has to be that y is positive. In other words, y is positive. They can't be both zero. One of them can't be zero, because if one of them is zero, then the other one will be zero. So y must be positive, minus y must be negative, and x is strictly between them. Okay? So I visualize it on the number line. Since they are numbers, they fall on the number line. Somewhere in the number line is zero. Y is somewhere to the right of zero on the plus side, and x is the corresponding distance. And minus y is the corresponding distance on the left side. So between here and here, between y and minus y, and so I read off what must be true. Well, the absolute value of x, whatever x is, and x has to be in between. X somewhere in between. And so, and x is never, it cannot be equal to y, and x cannot be equal to negative y. Okay, so x is in between them, which is the visualization of one, and y by this logic has to be to the right of the origin, greater than zero, and x might be negative, or it might be zero. So it's not true that this must be true. It can be true, but the question is which ones must be true. It's not this might not, this is sometimes not true, is sometimes not true. For example, when x equals zero, x could be here and z zero, or it could be on the other side of the origin. If, for example, x could be zero, or x could be negative. And so 1 and 2 must be true, not 1 and 3 must be true, not 2, and so the answer is B. Okay.
Okay.
How's that? That
Good.
makes sense?
It makes sense. Let me try another approach, okay? try another approach. I like what you were thinking here. This is really good stuff. You said these numbers must be positive, negative, or zero. So, if you're not thinking, which sometimes I do, I would say that X and Y could be anything they want because you could just do anything you want. So the answer would be one only.
No, you can't.
Seth,
you're told
Seth.
that that's true about them.
Okay, hold on.
You can't do anything you want.
Yeah, but maybe I could think about doing anything I want.
You could think about it, but that would violate what you are commanded to assume at the beginning of the problem.
Okay, so I have a different approach than
Insubordination in mathematics.
Seth, you're
Send them to the brig.
Seth, you're interrupting me. Let me finish my thinking, okay? Shh. Okay. So, at first blush, I would say that this would be the only answer because I could choose X and Y anything I want. So then I look at it and I say, well, the only weird thing here would be Y less than 0. Y less than 0, if Y is greater than 0, then of course this is true, and X can be 0 because, you could have a...
Okay, yeah, you're just confused. You're just adding hypothetical ideas that are ruled out by the very first line of the problem.
Seth, but I don't know that yet.
No, the very first line of the problem tells you what can be.
Right.
And also tells you certain situations that cannot be.
Seth,
so the efficiency is to rule them out and not even think about them.
Seth,
because you need the time to work on the next problem.
Seth, don't you understand?
Okay.
You are coming from the point of view of a PhD in math.
Well, I am, yes. We're trying to help other people get to that point of view.
Seth, very few people taking this test have a PhD in math, okay? Do you agree
That's for sure.
Okay, that's for sure. Right. So and excuse me, just let me do it. I'm coming from the point of view of not having a PhD in math, okay? Okay? So just humor me, okay? Humor me. I'm doing it.
He's funny. He's funny.
It's fine. You could laugh at me all you want, like I laughed at you a few months ago, and that was rude, and I apologize. I won't do that again. You can laugh at me now, but be quiet. Let me do it like someone who doesn't have a PhD in math. Okay. So, I look at this thing and I say, can X be 0? Yeah, X can be 0 because, look, you could go 3 and don't have that. Negative 3, right? Forget that. I didn't mean that, right? So, X can certainly be 0. So, I would definitely cross that out. That's obvious. It's almost, I hate to say what people say after this, but that makes sense. The question is, weird things happen. Let's check out when Y is less than 0. So let's do a Y is less than 0, and let's just see what happens. I could do that. Let's say Y is negative 5. Fine, Y is negative 5. If Y is negative 5, then the negative of negative 5 is 5, less than a number, less than
X.
negative 5. Now, I'm going to ask myself, does this make sense? Can you have a number that's less than negative 5? And frankly, this blows my brain, so I have to change this. But X is greater than 5. Can a number be less than negative 5 and be greater than 5 at the same time? No, it cannot. I would cross this out. So therefore, the answer could be this can.
Wait a minute. Wait. No.
No. I'm sorry. Yes, this cannot be true. This cannot be true. You can't have a number less than negative 5, greater than 5, which means that this cannot be. Y has, yes, this is true. Y has to be greater than 0, because if Y is less than 0, you get something that doesn't make sense. So therefore, Y is greater than 0 because this doesn't make sense, because I assumed it was less than 0 and I got nonsense. This is possible right here, and this also comes out of this. This basically says that X is between Y and negative Y. Like, 3 is between 10 and negative 10, which makes a lot of sense. So I would take a chance, and I would say 1 must be true, and 3 must be true. No, wait. 1 must be... Wait, I'm getting confused. Which must be true? No, this... Y,
1 and 3.
1 and 3. Right. Y has to be greater than 0 because otherwise you get
Uh-oh.
something that makes no sense.
Uh-oh. Did I cross circle this?
Right.
1 and 2?
You did this. I mean, the evidence is clear. Guilty as charged. You circled B.
Ah!
What, you got it wrong?
I got it wrong. I circled B.
Okay, let me have the honor privilege of figuring out what the answer should be. Which must be true? One must be true.
It's C. This is correct. I made a boo-boo.
Wow.
I said 1 and 3 must be true. So I looked for the answer and I circled B. That was I was too confident.
There you go. There you
go. You have to watch out. Even when you get the ideas right, and you pick the statements that must be true versus those that might be true or must be false, but not necessarily true, then you have to go to this A, B, C, D business and make the right combination and pick the right combination.
Yeah.
That is so. SAT, you have to actually check for that last opportunity to make a careless mistake.
Yeah. Also, there's a logic thing. Is this? Yeah. Is it this? Or is it this? Or is this? Well, hopefully you'll get enough practice. Everyone will get enough practice with these questions.
Yeah. Also, so I think, again, the both number of things you need to. Oh, well, what can I say? You have to think fast, avoid worrying about conditions that the data rules out, and then actually continue being accurate with the details of formula of picking the answer among the multiple choices.
Right.
And that's why PhDs in mathematics do not always get perfect scores on the math SAT.
Right. So, I can see you're a little mad at yourself.
I'm mad.
Yeah, I know. Well, that happens when you study for the test. You're going to make some stupid mistakes. You're going to be mad at yourself. Just try to make as few stupid mistakes as possible.
Yes.
So now, as I see it, there really are 4 possible ways you could go in this problem. One, you could not know at all what to do and just skip it and just get it wrong. One, you could do the way I was going, where basically set that way, and the X and Y could be anything, and you get that wrong. 3, you could do it the way the math PhD does it, namely my brother Seth, which frankly I did not quite follow. Or C, or I get another one, you could do it the way I did it, where you think, well, let's look at it and do it the way I did it. Or 5, you could do it another way. I wish we could take a poll. I wish we could ask people to raise their hands and say, how did they do it? But it seems to be like those are the only 5 ways, 5 possibilities. And, there's a number theory problem. And the thing about these problems is that you almost never get these in normal math in school. You get almost no experience doing this in actual class.
Well, if you had those questions in that class we were looking at, that textbook we were looking at with optimization, this is you get these issues there.
Yeah, but Seth, I showed you that textbook.
That's a high school. It is used in some high schools.
Rarely. But if anyone wants to know, that's a book called The Art of Problem Solving. It's from this franchise. It's a very, very, very high level textbook. It's used to train kids for competition, and only the honors of the honors classes in school use that textbook. Most people are not going to use that textbook in high school. So most people don't really get too many number theory questions in school. So you got to figure out what to do here. The other thing, can't you also test different? That's very inefficient. Just test a bunch of numbers and hope you got all the cases. That's the other possibility, is just make up numbers for X and Y and see when you get get a counterexample. See when you get something that doesn't make sense. Like Y can't be negative. In a problem like this,
well, that's an approach. It's not what's called mathematics.
Yeah, but it helps you get the question right.
It helps. It may help, and indeed, mathematicians do that when they have nothing, when they can't think of They can't think of they can't think of if a complete logical solution. They do that. That's
Right.
what you have to. That's the best you could do. You can't do better than the best you could do.
Right.
And then the point is, then what happens is when you realize or discover something that you hadn't thought of, then you might do better.
Right.
Yeah.
So that's sort of like what I did, right? I sort of
Yeah.
I tested the
yeah.
negative y because that's the case that's going to
Well,
make
with what you
strange.
did, what you didn't do
Yep.
was ask about the case of x equals 0.
No, I did. I did actually. I did
No.
that. I did it right here. When x is 0. When x is 0, it seems reasonable, but that's when y
Yeah,
is positive.
yeah.
What about x is negative? Wait a second. We never talked about that. Can x be negative?
Man,
Can
yeah.
x be negative? That's a wait. We didn't talk about that. What happens?
Yeah,
if
it could
x
be
is
there,
negative?
sure.
What happens? Okay.
I did with x equals negative.
Yeah,
X is negative.
Negative
Is
3
is in between there.
is less than 10 and negative 20. Right. Negative 3 could be between 10 and negative 20. Sure. And x could be negative. No skin off anyone's back. No skin off anyone's back. But did we test when x is negative and y is negative? Let's test that one. What about negative when x is negative? No. Wait. When x is negative, y is negative?
Of course. Could have y.
No, y can't be negative.
Y could be
negative.
Here's the origin. Y could be negative, right?
Yeah.
And x could be more negative.
Yeah, but y can't be negative. Y has to be positive.
Yeah. Well, no. If you exclude, let's see. No. Yeah. Y is negative. Yeah, if y is negative, right? Then minus y is on the other side of the number line. If y is negative, that implies minus y is positive.
Right.
But the condition of the problem says that y is to the right of negative y. So y cannot be negative.
Y
but
cannot be negative.
If you excluded, if you simply had x is less than y as a condition, with no, say you omit or remove the condition minus y is less than x, and you just consider this, then both of them can be on the negative half of the number line with x to the left of y. One of them could be on the right. You could have, do it on the number line. X could be here and y could be here. Or x could be here and y could be here. Or x could be here, negative, and y could be here. And of course, it also possible case is y is right on the origin, 0, and x is negative. Or x could be 0 and y is positive. All those possibilities are possible under the constraint that x is less than 1.
Yeah, but that's not the problem.
But then when you stuck a negative, then you take this, but when you append to x less than y condition, you take the y. This is the y, that's a number. You negate it. See, this is this y and this y are the same y.
Right.
You get from y to minus y by taking the same y, the same number, negate it, and then they combine it with the condition that what you get here is strictly less than x. And this x is the same x that's asserted to be less than y. And that connects the constraints, right?
Okay.
So that's
So how about that's all the theoretical stuff. I'm an engineer. Let me test what happens when x is less than 0, y is less than 0, okay? Just to be sure, right? Because you really, if I was to do the little game, I really have to check this case too,
yeah,
honestly, right?
sure, yeah.
So let's say x is equal to -3, and then y is equal to -5. So let's test that.
Yes.
So that would mean that 5 is less than -3, less than -5. So
Yeah.
-3 is not less than -5. So that's bad. But now, what
So
the
say
actual
use -7 for x.
And now I have to check the case. See, I checked the case where the absolute value of x is smaller than the absolute value of y. Now I have to check the case where the
No,
absolute value of x.
if you're checking this case,
Seth, please.
you also
Please.
have to
Seth.
take x equal to like -7.
Seth, you're not listening to me. Seth, can you please listen to me? Seth.
No.
Seth, please.
Okay, go
quiet.
on.
Seth, you didn't even listen to me. Now I have to check the case of here the absolute value of x was smaller than the absolute value of y. Now I have to check the case of the absolute value of x being greater than y. Being greater. So now I have to check the case of x.
Yeah.
Now, just to be spiteful to my brother, I'm going to check -10 because he said -7. So I'm being a little spiteful. So now I'm going to do y is equal to -5. Now we have the absolute value of x being greater than the absolute value of y. Now we have to check this. 5 less than -10 less than 5. Now, okay, good. -10 is -10 is less than 5. But is -10 greater than 5? No. So I checked both cases where this can't be. Now, I used up a massive amount of time, but now I'm pretty confident that I checked all the cases, and I can say that y has to be greater than 0. X can be 0 because we showed x can be 0, and number 1 is true because x has to be between y and -1. Okay.
Okay. Well, I know I'm surprised that you didn't consider another engineering approach.
Okay. What would that be?
You build it, right? You build a bridge. You build the towers, right? You set up the cables, make a nice suspension bridge, right? And then you lay out the decks. You hang them from the cable. Like this, Joe.
Yeah, I went through a stage in my life when I was really young where I loved bridges. I still like bridges.
Okay, now, you take the origin, the middle of the bridge is 0. You take on the right side the positive numbers.
Okay.
And on the left side, the negative numbers. And then you ask, where might x and y be? Right? Well, if y can, suppose y is negative.
Okay.
It's on the left side. Okay, is that possible? Well, then, okay, if y is on the left side, x has to be to the left of y. It could be, sure. But then negative y has to be even further to the left of the x. But y is picked to be, is here trying out y is negative.
Right.
Therefore, negative y has to be over here.
Right.
Right? And that being over here, it cannot be to all the way to the right of x, because this says that negative y is to the left of x. Right? So y is here, it can't be.
Got it.
What if y is 0?
Well, yeah.
Y is in the middle. Well, then this inequality says that x is less than 0 and is also greater than 0.
Right. Sorry.
Gosh. Well, on your bridge, you're either positive or you're negative or zero. You can't
Right.
be both
That's right.
negative and positive. So y cannot be here.
Right.
So y has to be over here.
Right.
Right?
Yeah.
And therefore minus y has to be over here on the left side of the bridge. Now, that where can x be? Well, you try x 0, 0. Yeah, that could be 0, 0. X could be right in the middle.
Yep.
X could be between the middle and y, and x can be over here. But the only thing that's because x cannot be on the outer x cannot be somewhere on the approach to the bridge. To the right of y, or to the left of y, of minus y. So that gives you all the situation. Then you read off the situation, the conditions that must be true, and you get the answer.
Right. Okay.
You're not picking. You're not here. You're drawing the bridge, and you're imagining where x and y are. You're not messing with these numbers like 7. What's 7 coming from?
Just a normal, just an average number.
Numbers 5, 3, 7. That's it.
Yeah. Okay, fine. Yeah. Okay, great. And this is the whole idea. A math PhD would do it your way. Some people who don't have
why wouldn't an engineer do it my way?
I have no idea.
Some engineers would do that.
It's pretty clear that there's no one way to do this problem. Some of the problems we have in this SAT thing, it's so clear. There's really just one practical way to do it. Here, it's really an open game. You do what works for you. So, okay. Wish we could give you a better approach, but we gave you a slew of approaches today, didn't we? On how to approach number theory problems. You could even approach it like a math PhD.
Well, okay. From mathematician language, in mathematics language, numbers are things that behave like integers. These are actually about these here is a more. I wouldn't call this number theory. I'd call this analysis.
Fine.
But that's professional snobbishness here.
Yeah. Okay. Number theory is close enough. The problem with number theory is that, you just got to practice these things, and you could see that you can approach them like a math PhD, which is one approach. As an engineer, you just have to get a little experience practicing. So practice on con. Do your best on these number theories, because there is no one approach that we could tell you that works for everything.
Mathematicians will say this is order theory.
Yeah, okay. Fine. Whatever. Okay. Then have a great day, everyone. And we'll, then like us, dislike us, give us comments, etc., etc. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. Bye-bye, everyone.
Bye-bye.